Per year, up to 5.9 million tons of medical waste are produced by hospitals, only in the USA. And amid the ongoing pandemic, this number could increase dramatically. Face masks, plastic masks, latex loops, among others, not only pollute the environment, but also they represent a biohazard. Also, medical gowns are used in every single hospital as disposable equipment. Most of the medical gowns are made out of polyester, which is a very pollutant material. Not only due to the fact that more than 70 million barrels of petroleum a year are needed to satisfy the polyester demand in the industry, but also because polyester clothes may persist in the environment for up to 500 years. These are the reasons that led us to create eco-gowns. For the concept, 4 characteristics are essential, this being that gowns are biodegradable, feasible, with an innovative design, and finally, that cover a real-life necessity. Eco-gowns are antimicrobial and biodegradable medical gowns, mainly composed of polylactic acid fibers and a starch-based polymer for the buttons. The design includes full coverage for the user. To put on the gown, it's inserted through the side opening and closed with the buttons provided. Finally, adjust the waist area with the strap. This combination of elements create a single-size gown, and the side buttons solve the problem of closing up the gown with multiple straps that tend to loosen through the gown usage.
The buttons used are snap buttons, as they are easier to install and quick to snap up compared to traditional buttons.
So, what about the materials?
Let's talk about polylactic acid. PLA is a thermoplastic polymer derived from renewable resources like cornstarch, tapioca roots, chips, and sugar cane. PLA degrades in up to 6 months if hydrolyzed and has characteristics similar to polypropylene, polyethylene, or polyestyrene. It can be produced by already existing manufacturing equipment, making it relatively cost-efficient to produce. Furthermore, PLA is malleable, and the characteristics of PLA-based textiles allow the addition of antimicrobial additives in order to create a safe material. The second component of the design are the starch-based buttons. Starch is a polysaccharide, which is composed of 2 subunits, amylose and amylopectin. Since the structure of starch contains a significant amount of hydroxyl groups, hydrogen bonds are easily made with polar substances, such as water. Hence, starch is a highly hydrophilic compound, so the ultimate goal of a fast biodegradation is fulfilled. In order to improve the resistance of the polymer, it will be composite with wood flour, and a UV light treatment would be implemented. As mentioned before, starch solubility properties allow them to be easily used and disposed of.
Antimicrobial finishing is an essential characteristic of single-use medical gowns, as it reduces the spread of microbes and virus around the medical facilities. For this purpose, an antimicrobial additive is added, such as the one from BioCoj. These antimicrobial additives for textiles and fabrics are easy to apply at any stage of the production process, making the material resistant to bacteria, fungi, and virus without affecting the characteristics of the fiber. The mechanism of production of the gowns and buttons would be: first, develop the previously described biopolymers and evaluate the physical and chemical characteristics it has. When the material is corrected to perform as desired, the creation of molds and clothing pattern is the next step according to the client's desire and application. The target market of this project will be the medical gown retailers that export or have presence in Mexico, and are specialized in retail to hospitals, investigation centers, and healthcare centers.
There is an urge for more eco-friendly medical gowns in the health industry, but They must be appropriate for all the stakeholders involved. Eco-guns are the best option to all reasons exposed before. Thank you.